Today we're talking about the law of cosines. The law of cosines is actually a set of 3 separate formulas. I'm going to show them to you one at a time. Make sure you write these down carefully, because obviously if you write it down incorrectly, you'll use it incorrectly. And before you ask, yes, these will be provided on the test. You don't have to memorize them. First one, a squared equals b squared plus c squared minus 2bc times cosine of a. After you write it down, make sure every symbol, every letter matches what I have up there. As you'll see, this pattern repeats, just putting the letters in different positions. Formula 2, b squared equals a squared plus c squared minus 2ac cosine of b. Make sure you do upper and lowercase accordingly. As you know, the lowercase are sides, the uppercase are angles. Last one is the c squared. C squared equals a squared plus b squared minus 2ab cosine of c. I'm going to leave that up here for about 20 more seconds, and then I'm moving on. We're going to do 2 examples today, 2 different types of problems. First example. Solve the triangle. Round to the nearest tenth. It doesn't say the rounding on the homework, but you'll check my key. The answers will be in tenths places. We are given B is equal to 10, C is equal to 12, and the measure of angle A is 58 degrees. We'll start the problem off like how we normally do. We'll draw the triangle, label everything, figure out what type of triangle we have, and then go from there. That is how you should approach every problem on the test. We have A, B, C. Sides, A, B, C. Filling in our known info, B is 10, C is 12. Angle A is 58 degrees. What is the configuration of this triangle? What 3 letters will be used? What order? Yeah? SAS is correct. So for those who don't see it, we have 2 sides here. And that A is for angle, not necessarily angle A. SAS, you have the angle sandwiched between 2 sides. That is different from the ASS case, which is solved in a completely different way. So this is an SAS triangle. Now the approach to solving. You already know we're going to use the law of cosines. That's why these notes are called law of cosines. Let's talk about why. To use the law of sines, you have to have the same side and angle for the same letter. We don't have that. We have angle A but not side A, and then we don't know angles B or C, so we can't use their sides either. We simply use law of cosines because we don't have enough info to use law of sines. That's how you're going to know how to proceed on the problem. So I'll make a note about that over here. Not enough info. To use law of sines. So we use law of cosines. From here, we need to figure out which formula we're going to use. So what I'm going to do, I'm going to fold this over and figure out how I want that to look. Give me just a sec. So I can show you the problem and the formulas at the same time. There we go. So it helps if you look at the given information and compare it to the formulas, because you can only use one of these three. If you pick out the wrong one initially, you're going to run into trouble, and hopefully you'll figure that out, turn around, find a different formula. Does anyone see which formula we should use here? Yes. The first one. We know B, C, and angle A, so we know everything over here. We're just missing the A. If I try to use 2 or 3, 2, I'm missing A and angle B, can't use it. And then 3, I'm missing A and angle C. If you have 2 things missing, you can't use the formula. You can only have one thing missing at a time. So we're going to use the first version of the formula. A squared equals B squared plus C squared minus 2BC cosine of angle A. I'm going to plug everything in. A squared equals, we know that B is 10 squared plus C is 12 squared minus 2 times 10 times 12 times cosine of 58 degrees. Now before you put it in the calculator, I want to show you one more thing, because that is what I'm going to do, is put it in the calculator. Let's completely solve for A. So we only have to put one thing in the calculator. What else do I need to do? Just square root. Yeah, need to get the square off of it. So we're going to square root both sides. Now put that entire right side under the radical. Put that into your calculator. And this will definitely be rounded. Yes.
Can you do that part after you do it at the end?
Like, are you saying get this number and then square root it?
Yeah.
Yeah, of course.
Okay.
And when you're doing this, after you're done, just go back over your work before you hit enter, because it is very easy to make a mistake when typing all of this in. If you did that correctly, you should get 10.8 when you round. So we got 10.8 for A. Now we need to find angle B and angle C. Now I'm sure some of you, your wheels are already turning and you're like, oh, I have both A's, I can use law of sines now. technically you would be correct. But the whole ASS issue, you can run into that here if you pivot and use law of sines incorrectly. Depending on which angle you're using, you may be able to use law of sines or you may not. So to avoid that issue from happening, my solid recommendation is once you start a problem with law of cosines, you finish it with law of cosines. So that's my advice. Take it or leave it. I'm going to write out basically what I just said. Once you start with law of cosines, I'll put must. It's doable with law of sines, but I don't want you to make a mistake and it costs you some points. Must use law of cosines. To finish the problem. If you pivot and use law of sines and it leads to an incorrect answer, just know you have been warned. If that's something you're more curious about, I'd love to explain it one-on-one, but I'm trying to avoid confusion, so I'm not going to go further than that. So on that note, we need to use law of cosines to find one of our missing angles. You can find B or C at this point. It's a personal choice. I always go alphabetical order, so let's find angle B next. And the first one I did, I found A. When you first dive into the formula, you aren't quite sure what you're looking for yet. It just depends on the givens, but I found A for that work. Now I'm targeting angle B. So again, we have to use law of cosines. So we're going to go with the second formula because that's the one that has angle B in it, and that's what I want to find out. Formula 2. B squared equals A squared plus C squared minus 2AC times cosine of B. I'm going to give you a warning. This work is far more involved than the work we just did. It's not just a plug it into your calculator and get the answer kind of thing. It requires a lot of algebra. I am going to go turtle slow through this problem. I will do one step at a time just on the first run through. After that, I'll do multiple steps in one. But I want you to follow everything I'm doing and make sure you are following the algebra steps to a T. Okay, let's plug everything in first. B is 10, so we have 10 squared equals, we have A is 10.8 squared plus C, which is 12 squared, minus 2 times 10.8 times 12. Cosine of B, we're looking for B. Again, I'm going to do this one step at a time so that we avoid mistakes. And as we go through this, this is the big issue. Remember your order of operations as we go. So I'm sure some of you are already eyeballing this whole line of calculations. Are like, I'll just put that in my calculator. Don't do that. That will be wrong. So, one thing at a time. We don't have any parentheses encompassing a calculation. So I'm going to ignore that. We're going to go straight to exponents. We're going to do exponents first. First we have 10 squared. 10 squared is 100. 10.8 squared is 116.64. Plus 12 squared is 144. And I'll bring everything else down. Minus 2 times 10.8 times 12. cosine of b. Like I said, I'll do one step at a time for this first run through. We've done exponents. Next is multiply or divide, whichever comes first, but we only have multiplication here. Next, we have multiplication in these three numbers here, -2, 10.8, and 12. So I'm going to multiply those together and get that number. Bring everything else down first. And I'm going to leave the negative out when I multiply. So I'm going to get a positive in my calculator. $259.2 cosine of b. And as you can see, I'm out of my room, so I'm going to go onto a new paper. I'm just rewriting the problem real quick. Okay. Next from PEMDAS is add or subtract, whichever comes first. I have addition here. So I'm going to add these two numbers together. We have 100 equals $260.64. And then bring down minus 259.2 cosine of b. Now, what we do next is easily one of the biggest mistakes I see on the test, and it's the reason why I'm going slowly this first time. What should we do next? Yeah?
You subtract 260.64 on both sides.
There you go. I was worried you're going to say subtract it with this number. Yes, we're going to move the 260.4 over to the left side. One of the biggest mistakes I see is students will subtract these numbers because they're completely ignoring the fact that it's being multiplied by that cosine of b. It's attached to that cosine of b. You cannot subtract those. So don't subtract these on the test. I'll see it happen. Make sure you're not the person who does it. Yes, we're going to move this over to the other side. That is what we will do. So minus 260.64 on both sides. That's going to leave me with negative 160.64 equals, and then I'll just bring this guy down, negative 259.2 cosine of b. What next?
Right.
Yep. Now we need to divide off that number to get it off of the cosine of b. That's going to leave us with cosine of b is equal to, I'm just going to bring this fraction down. At this point, because it may be tempting, don't go into your calculator. Wait till the very end to use the calculator to get whatever our answer is. Negative 160.64 over negative 259.2. And hopefully you already know what to do next. Just like what we did with the previous notes, how we took inverse sine, we're going to do the same thing, but it's inverse cosine. So over here, we're going to have inverse cosine. When it switches sides, it gains the inverse. And then just drop that fraction down into it. And then we will use our calculators and round. When you type this in, make sure you're using Cosine, not sine. It's a very easy mistake to make. $51.7. And lastly, we need to find angle C. That's the easy part. We have 2 of the 3 angles, so we can use 180 to get us that. Just subtract both angles from 180, and the remaining number is 70.3 degrees. And there you have it, a completed triangle. Questions before I move on to the next example? Hopefully you're able to follow that algebra pretty clearly. Hopefully the majority of you were able to. Like I said, I'll go faster in the next one. But that part does take practice. One more example. Same directions apply. I won't rewrite them. Solve the triangle, round to the nearest tenth. Given A is 28, B is 47, C is 58. Triangle, angles ABC, and sides ABC. A is 28, B is 47, C is 58. Hopefully you have no trouble identifying what type of problem this is. What do we call this? Side, side, side. We have all 3 sides. We have all 3 sides. No angles. If you're curious, angle, 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 A, that is not a thing. We never use that. So that is the last of them. All right, we need to solve. So clearly can't use law of sines. We have no angles given to us. We can still use law of cosines. Now the benefit to this one is we know all 3 sides. So we could use any of the formulas that we want. You have the choice because we just need to find all 3 angles. Again, I like to just go in alphabetical order. It makes the decisions easy for me. So I'm just going to start with angle A. So I'm going to use the first formula. First formula, A squared equals B squared plus C squared minus 2BC times cosine of A. Plugging in, A is 28 squared equals B is 47, C is 58, both squared, minus 2 times 47 times 58 cosine of A. As you can see, this is the more painful version of this problem where there's a lot more algebra, a lot more to do. Now I'm not going to go at a turtle's pace again on this problem. I will still do quite a few steps, but not as many as I did last time. I'm going to do as much as I can in each step as I go. So first step, I'm going to do all of the squaring, and I'll go ahead and multiply this out all in one swoop. So 28 squared is 784 equals, and I'm going to do this whole thing, 47 squared plus 58 squared, just all of it. Reminder not to loop this in with it. That in total gives you 5,573 minus, and then 2 times 47 times 58. That's 5452. Cosine of A. Again, fight the urge to subtract these two because this one's assigned a cosine of A. So we need to move this over to the other side. Subtracting, I now have negative 4,789 equals, now we just have this here, negative 5452. Cosine of A. Next, I will divide this off on the left side. And we now have negative 4789 over negative 5452 is equal to cosine of A. Final step. Inverse cosine to flip it over to the other side. Inverse cosine of that fraction. Typing that in. Reminder, make sure you're using inverse cosine. (28.6 degrees). We have angles B and C to find, so we're going to have to repeat that process again for one of those two angles. Again, I go alphabetical, so let's go with angle B. For angle B, I need the second formula. B squared equals A squared plus C squared minus 2AC times cosine of B. Plugging in, B is 47, A is 28, C is 58. Once again, I'm going to do multiple steps at once, and I almost forgot the squared on 47. 47 squared is 2209. Equals, again, I'm going to do these two numbers together, 28 squared plus 58 squared, that is 4148. Minus 2 times 28 times 58, that's 3248. Cosine of B. And from there, we solve for cosine of B. First, I'll move the 4148 to the left side by subtraction. That's going to leave me with negative 1939 equals negative 3248 cosine of B. Divide by the negative 3248 on both sides. negative 1939 over negative 3248 is equal to cosine of b. And lastly, we take the inverse. Inverse cosine of that number. Of course, if you want to cancel out those negatives, so you have to type them in, that's fine. I just haven't worried about it. $53.3 degrees. And we are only missing angle C, so we can use 180 to get us that one. (180) minus 28.6 minus 53.3 degrees is 98.1 degrees.